1500, right? 1500, again, doesn't matter if we use millimeters or triangles, whatever we want. We could actually just change it to triangles. We could say let x equal 1 and then just use the value of x, or let d equal 1, let d equal 1500 and then just use values of d. Doesn't matter much to me. Okay, so we've got this 20 is 1500 away, and it's going, if we put this force here, did I say this is going clockwise? That's anti-clock. Oh yeah, good, over at minus. Okay. This one here is also going, relative to z, is also going anti-clockwise. So I've got minus 20, which is 1500 as well. And then lastly, we have 3, which is minus 1500 away. Okay, now if we're taking an approach, I just like to write here that we're assuming tension, therefore anti-clockwise. Right, that's an anti-clockwise term. Okay, so let's rewrite that. What I'm going to do is I'm going to bring this c over here. I'm going to write this as, I'm going to add 1500 c to both sides, so I'm going to get 1500 c equals minus, it's a big number. I should be able to do that without worrying about my zeros in my head, but the answer is 30,000. And this one here is going to be, okay. So if I add those together, okay, and then I'm going to get C equals minus 3,400 divided by 1,500. Well, I could cross out those zeros. If I hadn't already typed in my calculator, I might do that. But the point is here that the answer is going to be negative. Therefore, my assumption was no good. Therefore, it's in compression. We assumed tension, it wasn't in compression. Again, you don't need to write that, I like that convention, right? Divided by 1,500 equals 23. We're in kilonewtons, yep. And that is in compression. Let's have a look. So, as we talked about here, we've got answers. I've got 1.5, 23C, a bit further ahead. 23C. Okay, I've got one of these signs wrong, which are 3. 3 is going clockwise. Ah, silly duffer. Okay. Now, it's worth talking about how many marks do you lose for that? Hard to say. Assuming that this part of the question is only worth 3 marks, which, let me have a look at the question. Yeah, I'll talk about that bit. Okay. So that's actually this. So this number here is less. Yeah, it gives us the answer of 17. Okay. So what I'm going to do is I'm going to scroll down on the page and just see how many marks the truss component of this question was. 2 marks. Okay. Hard to say. You're definitely getting 1 mark, no matter what. For 2 marks, you generally want the answer to be completely right. I would just say if I was marking this, I would be asking my senior marker to say, for that minor error where the student has, if they've written this stuff here to indicate that you've understood why things are positive or negative, and I've drawn some things as negative, I haven't drawn anything as positive there. And so the more marks there are, the more flexibility. So I guess it doesn't really matter, how you approach it. The thing is, the more working you show, the more likely you are to get that right. I mean, for me, I've been doing this a long time. I've done this question several times, and I still, in the heat of this moment, while I'm trying to do a whole bunch of questions, I've made that mistake. The point I'm saying here is if you show enough working out, you might get lucky and they might give you the mark. They might say it's a clerical error and we've understood that they've demonstrated enough knowledge to give the full mark. Anyway, 2 marks is a bit rough. Hard to give full mark. I don't know. Gonna move on. Okay. I will say nice and short, so that was good. Because I'm worried 7 of these may have been biting off more than I could chew. Again, videos explaining how to do that question. And they also at 17. Okay. This next question is, so we're up to 2016, and we are calculating the reactions. Now we may have to calculate the reactions, but we're going to ignore that if we don't need it. Okay, that's kind of the problem. We need to see the picture. Okay, we want to calculate the force and nature in member M. Happy to do that. That's what we're here to do. Okay, so we've got this guy here. This will be super quick. The only thing I'm interested in how many marks this is worth. So I'm going to put this cut through the line here. Now again, this is a situation where this is already the second time, I think 2nd out of 5 times that I've used the method of joints. What I'm looking at here is I'm saying, okay, well if I zoom in this location here, I have 3 forces acting. So I'm going to zoom in, right? If I had a magnifying glass, as I sometimes like to do, I'm zooming in on that location. Okay, so if I zoom in there, what do I see? Well, I see this member here that I'm just going to label P because I've got no other reason, nothing else to call it. And I've got M, which again I don't like, but then I have an external force of 54. Now, what I need to have happen here is I need to have enough forces to maintain an equilibrium. I've got 3 forces and they need to be in equilibrium. Now, I don't know the angles, but I can figure them out, and straight away I can say, well, if this is down, I need there to be an up. And the only person who can provide up, so this is kind of like our lone wolf method, that's effectively what we're doing here, is we're taking a moment and we're using the lone wolf method. I'm just doing it in the format of a method of joints. We're going to need some amount of up. And what we've said here is that if we've got 54 down, we're going to need 54 up in order to keep this thing balanced. But I'm going to just draw this diagram and I'm going to say that how I could draw, if this is going up, it's also going up and to the left, which means that P is going to have to be to the right. So how I can draw that diagram is I can just take this shape. I can literally, because it said drawn to scale, they're always drawn to scale except for that one that wasn't, and even then I still would have drawn to scale, is I would have just taken this drawing here and I just would have extended it until I had 54 millimeters. I know my angles are right because I've drawn it to scale. And I would just find 54 millimeters, and I'd say 54 millimeters, and then if that was 54 millimeters, I'd just find the other values. Now without being able to do that, we have to do some trigonometry, which is a bit of a pain, right? So that's how I would approach it. The other, so that's how I would draw this. But if once we know the angle, well then it's relatively easy. We can say, okay, I'm going to find the angle. So in this case here, it's drawn to scale, so you could just get a protractor. If you have a protractor with you, do that. That's a smart move. But let's assume you don't have a protractor, you just have a ruler. We can say that the ratio is 2 to 1. 2 to 1. So if I want to find this angle theta, I can use arctan, or tan to the -1 button. Arctan equals opposite over adjacent, 1 over 2. So if I type in tan, it's 26 degrees. 0.56. I don't use minutes, so I just use decimal angles. Okay, so in this situation, if we just use the lone wolf, what we could say here is, using the lone wolf method, we can say sum of the forces vertically equal to 0. If I've got, I can write that as a diagram, but what I like to do is I just like to draw it like this. I've got 54 down, which means I'm going to have 54 up. That 54 up is going to have to be provided as a component. So this is going to have to be 54. And if that's 54, well, what's this going to be? Well, again, we've got our angle of 26.6. So if that's the case, it's going to have to be a number substantially bigger, right? If we can see, if we're just drawing this to scale, it's probably going to be 120, something like that. Okay, so let's have a look. Well, this is our hypotenuse. Okay, so if we write, again, I said I probably wasn't going to do this much, sine theta equals the opposite over the hypotenuse. Algebra, I'm going to assume you know this algebra, is just to say sine theta equals opposite over hypotenuse. So therefore, I can just swap that. I can say hypotenuse equals opposite divided by sine theta. Okay, so now that I've got that, I'm just going to, up here, I'm going to write the hypotenuse is, in this case, our hypotenuse is unknown. We're going to call that m. That's what they called it. And now opposite is 54, and sine 26.6. Mathematicians would probably have a better way of writing that, but we're going to use 54 divided by sine, and we've got 120. I think I said 110 was my guess. So I'm pretty happy with that answer. Now, in this diagram here, we've said that this is going to have to be going into the node. If it's the arrow is going into the point that we're looking at, we're zooming in on this location here. If it's going into the location, that means it's compression. And the units are all in kilonewtons. So that's my answer. It's pretty easy. Let's see how many marks that's worth and check that I'm right. 2 marks. Okay, so again, you can find more detailed answer. I've got 120 there, and 123. Oh, that's the angle. 120.75. Yep, I'm happy with that within my degree of accuracy. If you're looking at the HSC answers, you might be a little bit confused as to why the angle is rotated. And to be honest, I'm not sure why the angle is rotated, but a bigger fish to fry in my life, so not going to worry about that one. Moving on. Next question. Okay, the 2015 paper. And again, there's solutions. I just accidentally closed it. Control-Shift-T. There we go. Okay. Determine the reactions at A. I'm not going to do that unless I have to. Determine the nature and the force in AC. Okay, good. I like this question. Okay. So first of all, we're finding this is the member in question. And if I just draw a vertical line, I can see that I get 3 unknowns. Now I could take the left-hand side, but I don't know the left-hand side, so I'm going to ignore that side. I'm going to instead redraw my diagram. And I'm going to draw the forces, all pulling out from the node. I've got, let's say I've got AC, BC, and AF. And I also have a force of 1200 and a force of 750. Okay, so that's my starting point. I've drawn a section, and now I'm going to decide how I'm going to find this. Well, my target is AC, and I want to eliminate BC and AF. Now, the first thing I can say is AC the only one who can take a vertical force? That's a reasonable assumption, right? You think, well, normally when we see these sorts of diagonal lines, we think, oh, well, it's usually going to be lone wolf. But no, not in this case, because AC and AF both have vertical components. So they're not the only, there's no one person, there's no one member that is taking all of the vertical or all of the horizontal forces. So we've got to find a different solution. The next thing to look at is there a spot, if I just draw a line along BC, and if I draw a line along AF, is there a point where they meet? And there is, at point E. So that gets us started. So up at the top we go. The sum of the moments about E equals 0. 0 equals, well, I guess I'm going to stick with my convention of writing unnecessary work. BC times 0 minus AF times 0. And then I'm going to say, using my black pen, 750 times 0, because that's touching, it doesn't have any force. And then I've got my black pen and I've got minus 1200, and it is 3 meters away. Alright, I might write it as 1.5 plus 1.5 and then just write 3 above. And then I have finally this one. Oh, okay, well I've got to find my perpendicular distance. Okay, I guess I did get a bit excited. I thought this would be easier than it was. Okay, so I'm just drawing that line. Does it say not to scale? It does not, so we can just measure using our scale. Okay, so this is our perpendicular distance. Okay, now me, I would, if I was in the exam, 100% I would be using perpendicular distance. I would just find it that way. But the problem is when you're doing an exam on paper, well, not on paper, gets a little bit tougher, a little bit harder to find that answer. So how am I going to approach this? Because I can't just, I could measure off my scale, I could measure off literally the screen. That's an option I have available to me. I can say, well, if this is 1.5, so it's probably going to be 2.5, and that looks like it's going to be, well, 1.5. Let's say it's probably going to be the ballpark of 2.5 meters. In the ballpark of 2.5 meters. Do I want to do trigonometry? I've already shown how to do trigonometry previously, so I don't really, I'm mindful of how I'm spending my Christmas Eve, but how am I going to approach it? Because it's hard to find this angle. To find this angle, I guess this angle, I'm going to call it theta, is the same as that angle there, right? So that's a bit of geometry, right? So I need to know that opposite angles, if I have this here, the opposite angles are equal. And so, well, that makes life easy. These are 45. It's the same on both sides. So in this case, it's going to be 45. And so that makes this one 45. Ha! Now suddenly I'm not so upset. In that case, if I have this diagram, okay, 45, and this here is 1 plus 1 is 3, so this is going to be 3. Well, this is going to be 70%, or 0.707 times 3. And that's just because I know that value. That's a regular triangle, 0.707. I have just learnt that trigonometric value. So that's going to be 2.1. I wrote 2.5, but I was pretty happy with that estimate. 2.12. Okay. So let's have a look at our forces. So we've got another little diagram here. That one I've ignored, ignored. So I've only really got two forces. This one and AC. Now, I wrote straight up that 1200, I wrote up that it was going anti-clockwise. I probably should have explained that. So if we're going around about point E, this is going to go anti-clockwise. AC, on the other hand, if we move this force up here, it's also going anti-clockwise. Well, we can't have two anti-clockwise because the clockwise forces need to balance the anti-clockwise forces. So I'm going to assume that's probably going to be wrong. We're going to start there, and we're going to write 2.12. Okay, we're going to bring this over here. We're going to make AC positive by bringing it to the other side. And we're going to have how many ACs? We're going to have 2.12 ACs. And it's going to equal 3 times 1200. I can't believe we've got a calculator out for that one. 3600. And then if I bought 2 air conditioners for 3.6 thousand, how much is each air conditioner? Well, it's probably going to be less than 2,000. So let's divide it by 2.12. There we go. 1698, which sounds about right. That seems. Now, the thing is here, that number is negative, and so I'm going to write my little note here of saying my assumption was wrong. The answer was negative, therefore my assumption was no good, therefore it's in compression. Because we assumed tension at the start. All our answers are in newtons, and this is in compression. Okay, let's have a look at our answer. And again, see how many marks it's worth. 3 marks for that one. That was probably because of the geometry. Yeah, Ali's got the same answer there. What paper am I on? 15. Yep, that's right. Good. Okay. Cooking. Only made 1 mistake so far. Just 2 to go. Okay, so the first thing I'm going to do is, we're not even interested in that part of the question. We want the truss. So they've given us 2 different questions, which I like, personally. Okay, they've asked us to find, for 3 marks, BC and DF. That's pretty good. I like this. I think it's a good 3 marks. So for BC, let's highlight the ones that they want us to do. BC is here, and DF is here. Okay, so how are we going to do this? Well, I'll start with DF. If I inspect this joint, if this has any amount of pushing to the right, there's nothing here that can push enough to the left. This and this have to balance each other, so this can't provide additional right, this can't provide additional left to balance that in any amount of right. So that means that this has to be a zero force member. And we can identify that by an inspection, because whenever we have a line and a single force attached to it, so a supplementary angle, with no external forces, it's going to have a problem. Here, this one is not a zero force member because there's a force being applied onto it. When there's a force being applied to it, it's no longer a supplementary, no longer just a simple 3 forces on a point. Now, the good question is, why would we have a zero force member? Well, it can prevent buckling, so it can prevent compression, failure in compression, or the load conditions might change, and under alternative load conditions, it could be a useful member. So if this load was moving over here because the wind shifted, then that might be the case. So designers, structural engineers have to design for a lot of different cases, load cases, based on different wind conditions. And in some cases, the wind can be helping you, and sometimes it can be hurting you. Look, I'm just going to draw a straight line. So I'm going to go with this location, and that cuts through BC with leaving only 2 unknowns. Now I have the choice of looking at the left or the right. Well, there's an unknown here, and here it's given. So I'm going to choose. It's actually pretty interesting if you take the left or the right. I don't care enough to do both, so I'm just going to pick one. Which one do you want, left or right?
Left.
Left, there we go. Okay, so we're just going to draw like Beyonce. 30, 22.5, and we've got BC, that's not how you write a B or a C, BC, BF, and AF. Okay, I would just say this here, hard to solve, right? That one's a hard to solve member because there's no really, the only way to cut it is through here, and then there's no external forces, so you have to cut through 4. So the idea is you have to solve this one, then that one to solve the CF. CF is very hard to do. It needs to be done progressively. Usually in the HSC they won't ask you to have to do one where you won't have to work backwards. Usually they'll give you something that you can solve straight up. But if you wanted to solve CF, you have to solve CF, but you have to solve either side first. You have to find BC before you can find CF. Or you have to find AF before you find CF. Otherwise you're going to have too many unknowns. Okay, so first thing I want to look at is, okay, well, with BF is my target, and I've got 2 unknowns, BC and AF. And I look at BF and I say, well, okay, is BF is it lone wolf? And is BF the only one who can take a vertical force? No, because BC also has that training. He can also take a vertical force. So that's not going to be our answer. So it means it has to be meet up. And we can solve where we're going to find our meet up point. BC meets up at A, and AF meets up at A. So we're going to take moments about A. So right up at the top here again, we're going to write sum of the moments about A equals 0, 0 equals. Okay. First of all, we have, and I'm going to write this in blue because it's not necessary, 22.5 brackets 0, because it touches A, so it's going to be 0 distance. The next one is 3. Well, 3 is, if this is 15 meters, then this will be 7, and that will be 3.5. Now, generally in the brackets, I might write, well, you know, I will actually write it in brackets. So I'm going to say 30. Now, I've written minus 30, brackets 15 on 4. But is that going clockwise or anti-clockwise? Relative to A, that 30 is going clockwise. So we're going to change that sign to a plus. The next one we have is BC. BC is 0, so we go back to the blue. Right, minus BC brackets 0, and then we have BF. You know, I'm going to bring that down here. BF. Okay, so BF distance, what's the perpendicular distance? Oh man, they love to give us these perpendicular distance questions. Okay. So I'm drawing that line out all the way, and then I'm getting my set square. I don't know how you could be doing an engineering test without bringing a set square. And we're going to find that perpendicular distance. Okay, how am I going to do that? Well, I've been told this angle here is 30 degrees. I can tell it because it's symmetrical. So let me draw that triangle up here for you. I'll draw it here. So that's 30 degrees, and this is 7. So if we look at our diagram up the top here, the small side is always exactly half the long side on a 30-degree triangle. So that's easy. We've got that value. So I'm going to write here BF. Now the question is it going clockwise or anti-clockwise? Relative to A, is BF going clockwise or anti-clockwise? It's pushing clockwise. BF is pushing clockwise. So plus BF, and its distance is 3.5. And then finally we have AF, which again we can ignore. Now, I want to write here, it's only clockwise if it's tension. So I'm going to write here, assume tension, therefore clockwise. Okay. 0 equals $30 times 3.5 and okay. So it's 105 plus 3.5 BF. Now, just checking that they're both clockwise. They're both clockwise. Okay. When I move this over to here, I'm going to get minus 3.5 BF. Minus 3.5 BF equals 105. Therefore, so if I bought 3 burger friends for $105, that means probably each burger friend is going to cost, oh, okay, before we get to that stage, we can tell here that at this point that BF is going to be negative. So we can write negative, therefore, assumption was no good, therefore, compression, because we assume tension up above. Okay, so if we had 105 divided by 3.5, well, it's going to be literally the same answer as above. It's going to be 30. So that's going to be in kilonewtons, and our assumption was no good, so therefore it's going to be in compression. Okay, let's see how we did. Oh, I don't have it set to the answers, but again, you can see there's a video. Huh. Don't miss a force. Okay. This is cancelled because multiplies by 0, multiplies by 0, multiplies by 0. This distance is the same as BF. Oh, okay. Didn't read the question. Oh, this would be interesting. Okay, so it's a 3-mark question. Straight away, you're getting 1 mark for getting DF, right? Straight away, you're getting that. So what I've done wrong is I have found BF, not BC. Now, if I was marking this straight away, I'd call a senior marker and say they've just misread the question. I probably wouldn't do this in the exam as well because you would see as you're writing it in there BC, but I'm writing on the board. Okay, well, make me feel better that I haven't got 2 things totally wrong. I've just found the wrong thing. I guess the point here, the take-home message, always trying to be learning from mistakes at this point rather than excusing mistakes, is what we want to be doing is we want to be learning from it and saying, okay, well, in the exam, we need to be making sure that we're reading the question. So what we need to find is BC. Yes, I just got excited. It's funny, I think I had that earlier, but somewhere along the line, I did that wrong. Okay, marked it out earlier. Anyway, so let's have a look at I'll just draw this diagram again. BC, BF, and AF. Okay, in this case here, well, the location, let's how are we going to find BC? It's not lone wolf, because we've said already BC and BF, they both can take vertical components. So what we're going to do is we're going to take moments about F. AF and BF, both, surprisingly, they both share a letter. Good chance that they're going to be in that same location, F. We haven't seen that so far, them sharing a letter, because usually they've been a bit tricksy. But in this case, we find it, and even though the BF, the location F isn't on our drawing, that's okay. We still can take moments about there. Okay, this actually is probably easier than before. Our perpendicular distance that we found, I'm just going to draw this up here. That is, if we know this is 7 and that's 30 degrees, that's going to be 3.5, even easier than last time. Just that ratio of big side to little side is 2 to 1. Okay, so what we've got now, if we have our perpendicular distance, let's go back to it. I'm just going to write this out. I'm not going to worry about writing all the unnecessary stuff here. I'm just going to say we really only have two forces. We have 22.5 is the force, and it is 7 away. It is clockwise relative to F. It's interesting to note that forces, this force was 0 before, right? And the 30 that we're going to look at, the 30 was clockwise before, but now that we've moved our force, this is now going anti-clockwise. This 30 is now going anti-clockwise relative to F, where it was going clockwise relative to A. So, if nothing else, you've got a bit of bonus. I mean, I'm embarrassed, but aside from that, you know, you have at least got additional learning out of this. Okay, so what we've got is 30. I wonder if you're like screaming, if you're like, Barnes, you're doing the wrong one. 3.5, and then finally we have BC. Is BC, we're going to assume that BC is going clockwise, right? BC is going clockwise around F. So we're going to say plus BC, and BC is 3.5 as well. Okay. I need a calculator. There you go.